Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the directional derivative and the gradient vector. So first of all, what is a directional derivative? We have to know about the directional derivative. It is used to find the slope in the two dimension, slope of a surface. So here, it used to determine the slope at a point on a surface. So you can define the derivative which is called as a directional derivative. Let us take an example of the real world problem. We will have a directional derivative tells the slope of this curve. This is a hill in this tree. So we have to find the slope of this curve in the surface. So this is the directional derivative is used. Now, it is also used to find the rate of change of the function on the two and more variable, the directional derivative. Now, we will go to the next one, the formula here. This is a derivative formula we have, but we will use this one as the main formula. So here, if the unit vector is given by the angle, if it is given in the terms of an angle, so the unit vector is given by u equal cosine theta comma sine theta. So fx the partial derivative with the first derivative and the fy partial derivative with the respect to y, and it is a sine theta and cosine theta you have to multiply. Whenever the theta is given, we are going to use this derivative formula. When it is a vector, the unit vector is given, we will use this formula. So in place of cosine and sine, we will use directly the a and b, the given vector. So this is the difference between the directional derivative. Whenever the angle is given, we are using this rule. Whenever the unit vector is given, we are going to use the second formula. Now let us start with the first one here, the problem. So here we have to find the directional derivative of a function in which it is given as the theta. So see here, if the theta is given, so we have to use the first formula. So what is the formula here? I write it the formula first. So here this is du of directional derivative of f of x comma y, it is given by fx of x comma y, and then cosine theta plus fy of xy sine theta, sine theta. So what is a u vector? That is a cosine theta. Theta value is given by pi over 6. Pi over 6 is nothing but 30 degree. What is cosine 30 degree? So it is equal root 3 over 2. Root 3 over 2. And what about the sine pi over 6? So which is equal sine 30. Sine 30 is 1 over 2. 1 over 2. Now I just substitute the values here. What are the things we have to find it here? So the formula is given by replace x and y, the points x comma 1, 1 comma 2. So first of all, we have to differentiate this part. What is the differentiation of with respect to x? So here we have to differentiate with respect to x. It is 3x square minus 3y. There is no x term 0. This is done. Plus, what about this part? With respect to y. So here there is no y term 0. The next term it is minus 3x plus 8y. After that, I have to substitute the theta value. What is this one? Sine theta and cosine theta. Just we have calculated here. So cosine theta, which is pi over 6, is root 3 over 2. And here it is 1 over 2 is a sine theta. After that, this is the problem. This is the formula for the directional derivative of the any point. But in the problem, it is asking the find the value of x equal 1 and y equal 2. So I have to replace x is equal 1, y is equals 2. So you will get the value directional derivative of 1 comma 2 is given by, if you substitute 1, it becomes 3 minus this is y is 2, it is 6 root 3 over 2 plus here minus 3 plus 16. 8 into 2, which is 16 into half. So if you simplify this one, you will get, so it is minus 3 root 3 over 2 plus 13 or 1 over 2. So 1 over 2 is a common. So this is minus root 3 over 3 plus 13. So this is the final answer you have for this point. So this is a directional derivative. The next one, it is the gradient vector. So how will you calculate the gradient vector of the two variable? So gradient of vector is nothing but it's a vector function in which you have to find it the fx and fy. So or you can write it in the vector notation fx over fy dou x over dou y into j vector. And very important thing here, the gradient, it can be written in terms of gradient f or del f. Both are same notation, but only the notation is different. And the next one, it is a gradient directional vector. What is the relationship between the directional derivative and the gradient vector is the directional derivative equals gradient vector into unit vector. You will find it a directional vector. So whenever the gradient vector is given, we will calculate by multiplying the unit vector. You will find it the directional derivative. Let us start with this one. This is a problem for only gradient vector del. That's it. So I have to find it this one in terms of x, y you have. So del of x comma y, which is given by fx and fy. So you have to write it this one fx and fy, or you can write it in terms of this notation as well. Dou f over dou xi vector plus dou f over dou yj vector. Both are same notation. Now I have to differentiate partially with respect to x. So what happened here? So this is equal. So x differentiation, sine differentiation, cosine plus e to the power xy as it is into y. So this is the I vector plus the j the with respect to y. So how will you calculate with respect to y? So here there is no y term, 0 first term plus e to the power xy as it is. Y become 1, you will get x. This is the j vector. So this is the gradient vector at any point which is given by del f of x comma y, or we can write it this as gradient f. Both are same notation. Equal, this is cosine x plus y e power xy into I vector plus x e power xy into j vector. So this is the any point. Now in order to calculate the next one by substituting the value, you have to replace x is equal 0, y equal 1. So you will find it the del f of 0 comma 1. X value 0 means cosine 0 is 1 plus this is 1 e to the power 0. So I vector plus x0, the entire term becomes 0 because you will have the value which is equal what? This 0. So entire term becomes 0. This is 0 I. So here you will find e power 0 is 1 plus 1 which is 2I plus 0 j. So the j component is 0, or you can write it in the form of 2 comma 0. So this is the final answer. Now the next one here, in this case, it is given as a directional derivative. You have to find it. Find the directional derivative of the function which is given at a point in the direction of the vector. So it is a direction vector is given. So you have to find it the unit vector here. So first of all, I have to calculate the gradient vector. So here, in order to calculate the gradient vector, we cannot apply this rule because here there is no angle is given, there is no theta is given. Here there is a one directional vector and a point is given. So you have to find it by using that rule. So this is a very important rule. F of x comma y directional derivative is equal del f of x comma y into the unit vector. So this is a very important formula we are going to use in all the problems. So whenever the point and directional vector is given. So first of all, I will calculate the point. First, I will calculate mm, the gradient vector. So what is the gradient vector here? So gradient f or f of x comma y, which is given by fx comma fy, fx comma fy. So what is fx? Here it is dou f over dou x I vector, dou f over dou y j vector. Now when you differentiate this one partially with respect to x, you will get it this one as, so this is 2xy power 3. That's it. There is no x term in the second term. My plus the y with respect to y. 3x square y square minus 4. So this is the j. Now I have to find it this gradient vector at the point. At the point. So you will find it this one del f of 2 comma minus 1, which is given by substituting the value. It is 4. It is minus 4I. So I replace here the x and y value. Then plus, if you substitute here, it becomes 4. 2 square is 4. 4 into 3, 4. 4 into 3, 12. 12, which is minus 1 square, which is positive. It is 12 minus 4 into j vector. If you simplify this one, the vector will be given by 4i plus 8j. So this is the gradient vector. So this is done. This part is finished. Now let us go with the next part here, which is the unit vector. This is the unit vector of the directional vector. So how will you calculate the unit vector of any vector? Unit vector is given by v over the magnitude of v. So this is a unit vector. So what is the v vector? Magnitude of v, which is equal square root of 4 plus 25, which is equal root 29. Root 29. Then we divide it, you will get the value is equal 2 over root 29I plus 5 over root 29J. So I just put it here. So this is the unit vector. So done. Now just you have to take it the dot product of these two, the gradient vector and the unit vector, you will find it the directional derivative. So I write it the directional derivative is equal at the point. The directional derivative at the point 2 comma minus 1 is given by gradient of 2 comma minus 1 into u. So the u is a unit vector. Now when you multiply this one is what? Here you will have the 4 comma 8. Then the unit vector which is given by 2 over root 29 and 5 over root 29. 5 over root 29. When you multiply this one, you will get minus 8 over root 29 and then plus 40 times 40 over root 29. So therefore, the value will be root 29 is a common here. So you will get 32 with the positive value. You will get a scalar quantity at the last, the directional derivative. Now, very important note here, the we will call it the directional derivative as also the rate of change. Now, if you want to calculate the maximum value of the directional derivative, so I will take the absolute, that is the magnitude of the gradient vector. So that gives the maximum value. And here the rate of change, which is we can write it as directional derivative. So if the question is asking the word only change, but the remaining thing will be the same thing what we defined before. So if you see here, there is a word, it is given find the rate of change. Rate of change is nothing but directional derivative. You have to find it the directional derivative. Same story you have to repeat again. So here you will have a point and there is a 2 point is given. The directional vector is missing here. So how will you find that one? So this is somewhat difficult. The different problem we will have here. The f is clearly given, which is x e power y. That's it. Okay. Next, I have to find it the gradient vector. What is the gradient vector? Gradient f x comma y, which is given by fxi plus fyj. So what is fx here? It is e x become 1 e power y. plus here fy. So x is a constant, e power y is the e power y differentiation as it is. Now I have to find it the point. The initial point is always the p value. So you have to substitute x and y this point, the p point. So what happened here? The gradient vector of at the point 2 comma 0. So y0 means e power 0 is 1 plus 2 times of I. So you will get the vector 1 comma 2. So this is a gradient vector. Now I will calculate the next part, which is what? The vector. So in order to calculate the directional derivative, we need this rule, right? So directional derivative is given by the gradient vector at the point into u. So in order to calculate the u, we need the directional vector. But for the directional vector, we need the 2 point. It is given in the 2 point. So just subtract it. So I will form the vector first. So vector which is equal PQ. Now subtract this one. So here you will get what? Half minus 2, which is equal half minus 2. This is the I component. 2 minus 0 j component. So therefore you will get here 4 minus 3 over 2 comma 2. So this is the vector. When you take a absolute value, this is the magnitude of this one in order to calculate the vector. So what is the magnitude of this? Square root of 9 over 4. 9 over 4 plus 4. So which is equal square root of 9, 16 plus 9, which is 25 over 4, which is equal 5 over 2. So this is the value. Now I will calculate the unit vector. What is the unit vector here you will have? So therefore I will divide this part. When you divide it, you will get. So I will divide this. So here the unit vector is given by the vector over the magnitude of that vector. So here the vector is given by this one. So if you divide it, you will get what? 3 over 2 over 5 over 2. Next, 2 over 5 over 2. So when you cancel this part, cancel, it goes to the numerator. So final answer will be minus 3 over 5, comma, it is 4 over 5. So this is the unit vector you will have. Now I will take as it is the next one, which is what? The directional derivative. What is the directional derivative? Just you have to dot product of these two. What is the dot product? It is 1 into 2 dot. It is a unit vector which is given by minus 3 over 5 comma 4 over 5. Now if you take a dot product of this one, minus 3 over 5, 1 into this one, same thing. Next multiply by 2, you will get plus 8 over 5. So which is equal 3 over 5. So this is the directional vector here. The only difference here, the directional vector, sorry, 3 over 5. So this one is a minus 3 plus 8. So it becomes minus 3 plus 8. Minus 3 plus 8 over 5, which is equal 5 over 5. So it is equal 1. So this is the directional vector. Now what is the next one? It is asking find the maximum rate of change. So maximum means you have to take the absolute value of the gradient. So maximum value which is given by maximum value the rate of change. So we say maximum rate of change is given by the magnitude of the gradient vector. Magnitude of the gradient vector 2 comma 0 at the point. So what is the vector here? We have the vector is given by this one. So 1 comma 2 is the gradient vector. Take the magnitude of this. 1 squared is 1 plus 2 squared is 4, which is equal root 5. So this is the root 5 is the maximum rate of change. Now the last problem of this topic we have here, the same thing, but it is a 3-dimension. Same story. We are dealing with the 2-dimension here, x, y only, but here you will have x and y and z. So let us go with this one. Same rule, nothing changed, no new things. So I have to do it the three things. What are the one? First, I will calculate this is the value you have x comma y comma z. So you have x comma y comma z, the gradient vector of x comma y comma z into the unit vector. So first of all, I calculate the gradient vector f comma x comma y comma z. So which is equal fxi fyj plus fzk. Because it is three dimension, we have to extend the formula up to the three dimension. Now differentiate with respect to x. So when you differentiate with respect to x, you will get y minus y square z square I plus, when you differentiate with respect to y, you will get x minus 2xyz power 2 into j. Next, plus z. What is z value here? We have, so it is minus there is no first term z. So it is second term, you have 2xy square z into k. Now I have to put it, this one is a point. The initial point is the p point. So I have to substitute del of the gradient of f at the point 2 comma minus 1 comma 1. When you substitute minus 1 here, you will get minus 1. Here it become plus, here it become plus, minus 1 I plus, then 2 minus, it become plus, so therefore it becomes plus 2 j. Next plus, this is z square, you have z square here. So what happened? First one, this is minus 2, the second one is I square, 2 into 2 which is 4, it becomes 4 plus, when you substitute the value here, the x value minus 4, so it becomes minus 4j. So what is the final answer? The vector is minus 2i plus 6j minus 4k. So this is the vector we will have, or you can write it in this format as well, minus 2, 6 and 4. So this is the gradient vector. Now I have to go with the direction vector. In order to calculate the direction vector, we have to find it, this one, PQ. So this is the unit vector is given by PQ over the magnitude of PQ. So I will first find the PQ. What is PQ? So subtract 5 minus 2, which is equals 3, comma 1 minus of minus, it become 2, 7 minus 1, which is equals 6. Now what is the absolute value, that is magnitude of this one? 9, 4 and 36, which is equal 49, which is equal 7. So the unit vector is given by 3 over 7, 2 over 7, 6 over 7. So this is the unit vector we will have. Now I will take the dot product of this one. This is the equation number 1. Now the final step, I have to take the d of f of at the point, the initial point, which is p. So I have to take a dot product of the gradient vector at the point, same point, into the unit vector u. So what are the vectors you will have? Vector for the gradient is minus 2, 6 and 4, minus 4. And whereas the dot for the u vector, which is equals 3 over 7, 2 over 7, 6 over 7. So now we will take a dot product. When you multiply, you will become minus 6 over 7 plus 12 over 7 minus 24 over 7. So when you divide this one, you will have over 7 is the same common term. Now when you add this one, you will get here 30. So minus 30 plus 12, which is equal minus 18 over 7. Thank you.